Alright, I've been sick recently, so hopefully my voice doesn't sound too bad. Today I am doing circular motion. That's awful. Alright, so let's pretend first that I can draw a circle. And we're going to assume that this is a satellite in space. And it's really far from the Earth, but not so far that the gravitational pull from the Earth doesn't act on it. Here's your satellite. Let's say it's moving this way. We're looking down onto the Earth. It has some speed, v. It is some distance, r, from the Earth. And that looks like some weird little happy smiley face. So there are a few properties that we need to go over. There's a t, which is the period. That's how long it takes to go around one time. So v is equal to 2 pi r over t by definition, because the speed at which it is traveling is equal to the distance, 2 pi r, divided by the time it takes to cover that distance. Keep in mind that this is often labeled velocity. However, the velocity depends on the direction it's traveling in as well. So it's better to think of it as a speed, but you can think of it as like a circular velocity. Next, we have an acceleration because the velocity is changing direction, even though it is not changing magnitude. And then you have a centripetal force, which is v squared m. Just my bad. V squared r times m, right? Because it's equal to mass times the acceleration. This is the force that is acting on the satellite and pulling it down towards Earth. So if you have a satellite, for example, F equals v squared over r times m, but F is also equal to big G m1 m2 divided by r squared, and these would be equivalent in this case alone. If you're just swinging an object in a circle, then you only get this equation. You don't use the second one. This is a gravity equation, which if you want to know like why that is, you should watch the other video for a touch-up. And I think this is everything on circular motion that's basic. One of the more complicated things to think about is what's called angular velocity. So this is an angle, right? It travels angularly, we'll call it theta, around the Earth. So it starts at theta equals 0, let's say, and it travels to some other degree level, and it will travel 2 pi, right, in radians, as it goes all the way around over t, the period, and this is equal to omega, which is called the angular velocity.